Hopefully you pushed pause on the previous video and tried these two problems on your own. If you haven't done that, make sure you do that before I complete these two problems. We want to evaluate the antiderivative or the integral 1200 e to the 0.4x, and we want to integrate 8x minus 2 over x with respect to x. 1200 e to the 0.4x, we know using our rules that if we're going to integrate e to a linear power, we can just rewrite e to that linear power and then divide by the coefficient of x out front. Once I've done that, I have to tack on a plus c because we're finding all antiderivatives. So all antiderivatives are going to be equivalent to 1200 divided by 0.4 e to the 0.4x plus c. 1200 divided by 0.4 is 3000. You can rewrite this expression as 3000 e to the 0.4x plus our constant c. That is the indefinite integral or the class of antiderivatives for this function 1200, e to the 0.4x. If I want to find all antiderivatives of 8x minus 2 over x, one thing you can do is you can rewrite or re-envision that 8x minus 2 over x as 8x minus 2 times 1 over x. Normally, I don't write this step. Once we've done a few, then this step will not be written out. But I want to write this at least for right now so that you see you can always, if I have a constant number up top, I can always bring that out front. Antiderivative of 8x, well, one antiderivative is x squared times 8 over 2. So 8 over 2 times x squared. Antiderivative of minus 2 times 1 over x is minus 2 times the natural log of x. Remember, I want to put the x in parentheses when I write that in Moodle. We understand that only positive x values can be plugged in to natural log. I'm going to simplify that 8 over 2 and just write that as 4. Hopefully that's not too big of a step to not write out. Therefore, my final answer is 4x squared minus 2 times the natural log of x plus c. That's how we find these indefinite integrals.